All right, welcome to OnlineMaths TV again. My name is Jakes Anemo. If you're new to this channel, this is a channel where we drop mathematics every day. And here we have an exponential question or challenge. And in this challenge, I'll just say a particular thing I want to bring to my viewers and my subscribers. Now, the question says x to the power of 6 minus x to the power of 3 equal to 2. What there will be the value or all the possible values of x? Now, if you look at this question, definitely this is a 6-degree exponential, okay? And so we are expected to get solve for 6 zeros of this equation. Now, I'm going to use two methods to handle this question. The first one will only bring out just two zeros of this exponential, okay, which are probably the real root to this exponential. The question is, when are you to use the first method or the second method? And the second method will bring out all the 6 roots or the 6 zeros of this exponential equation. And so I want you to sit back, relax, and we go into this. Okay, at the end, I will tell you when to use the first method and when to use the second method in case of any examination or competition. Okay, so from here, let's take our solution here. Selection. Let's take the first method to this. So let's put here first method. Let's put down our question, which is x to the power of 6 minus x to the power of 3 equal to 2. Okay, now in this first method, let's take a look at the smallest power here, which is x to the power of 3. I want to bring out x to the power of 3 from this. We know that 3 times 2 will give us 6. And so I can rewrite this expression here as x to the power of 3 times 2, okay, minus x to the power of 3 equal to 2. Now, in this regard, there is a law which says that if you have a to the power of m n, this is equal to your a to the power of m bracket or into n. And so if we succumb to this rule, we can rewrite this and put the x to the power of 3 in bracket. And so this will give us x to the power of 3, okay, all to the power of 2 minus x to the power of 3 equal to 2. Yeah. Now, at this point, we now have x to the power of 3 here and x to the power of 3 here. We can now bring in another alphabet to represent x to the power of 3. In this case, let's make use of p, okay? So here we'll say let your p equal to x to the power of 3, okay? Let me write it where x to the power of 3. So wherever we see x to the power of 3, we'll put in p there. So our equation will now automatically become p squared minus p there. Bring these 2 to this other side to give you here minus 2 or equal to 0. Okay, as you know, this is a quadratic equation, so we solve this quadratically. And solving this quadratically, let's think of two numbers that when we multiply by themselves will give us minus 2, add the two numbers together to give us minus 1. Of course, the two number will give us here minus 2 and plus 1. Okay, so if we do that, this will give us here p squared minus 2p plus p minus 2 are equal to 0. Okay, at this point, we can put this in bracket, also put this in bracket, then put this in bracket. Mind you, we have our blocks here, please. Okay, we have our blocks here. All right, so we want to factor out terms that are common to the bracket. So from here, p is common here, so we have here p bracket, p minus here, we're left with 2, close bracket, plus what is common here is 1, bracket here, we are left with p minus 2, close bracket, or equal to 0. And so from here, we discover what we have in here is the same thing we have on this other side. Okay, so the two brackets now, they are the same. We take only one and take this term that is outside and this that is outside. So with this, let's proceed from here. Okay, so let's proceed. Okay, if we proceed, we're going to have this to be P minus 2 close bracket, the bracket P plus 1 or equal to 0. And so let's equate this to 0, equate this to 0. So we're going to have this P minus 2 equal to 0 or P plus 1 equal to 0. So here we have this to be 2 or P equal to minus 1. Okay, so therefore RP is equals to 2 or minus 1. But recall, at first we don't have P. So we now remember where we said let P equal to x to the power of 3. Okay, so we now take question 1, but before then, we now say recall that P is equals to x to the power of 3. So if we take case 1, so we have here case 1, when our P is equal to 2. So we're going to have this to be x to the power of 3 equals to 2. We take the cube root of both sides, and so this, we take care of this and this to this. And so this we go with this, and x is going to give us here 2 to the power of 1 all over 3. This is the first root to this expression here now. Okay, we now take case 2. Case 2 says, case 2, we have our P equal to your minus 1. And so we go again to say here we have x to the power of 3 equal to minus 1. If we take the cube root of both sides again, this will leave. Okay, so let's proceed again from here. 3 here, please. So we're taking the cube root of x. And so here we're going to have our x equal to your minus 1. Okay, so this is the second value or root to this exponential equation. You now discover that from this first method, we're able to solve for only 2 roots of this sixth degree exponential equation. Okay, and so let's go over to the second method. Now, in this second method, there's a manipulation we're going to do here that will enable us to get the 6 roots outwards. Okay, now if you look at this now, I want to rewrite this equation again by bringing this 2 on the right hand side to the left hand side. And so this is going to give us here x to the power of 6 minus x to the power of 3 minus 2 equal to 0. Now, if you look at this minus x to the power of 3, if I rewrite this could also be written as minus 2x to the power of 3 plus x to the power of 3. In other words, if I rewrite this expression here, we're going to have x to the power of 6 minus 2 to the power of 2x to the power of 3, then plus x to the power of 3 minus 2 equal to 0. Now, you may ask, why did I decide to use minus 2x plus x? You could as well use minus 5x plus 4x. But if you do that, you're going to run into trouble. So I decided to use this because of the presence of this 2 here. Okay, hence I decided to use this minus 2x to the power of 3 plus x to the power of 3. So with this, we can group this and group this. So if I write this, we have here x to the power of 6 bracket minus 2x to the power of 3 bracket plus x to the power of 3 bracket minus 2 bracket or equal to 0. So from here, let's factor out x to the power of 3 because it's common here. And so we're going to have here x to the power of 3 bracket. Here we're going to be left with x to the power of 3, then minus, here we have left with 2 close bracket plus, here just 1. So we have 1 into x to the power of 3 minus 2 close bracket or equal to 0. Okay. If you now look at this, the terms in the bracket are the same. So we can take one of them and take these and these that are outside. And so if we go by that, we're going to have this to be x to the power of 3 plus 1 close bracket, which is this, and take one of this. So we have here x to the power of 3 minus 2 close bracket. Everything here equal to 0. Okay. If you look at this, if we put in x to the power of 3 plus 1 to the power of 3 is going to give us a special algebraic identity. Then we can equally manipulate that same identity from here too. Okay, from here, let's proceed first. If we take, we can raise this to power 3. We can equally raise this to power 3 all over 3. Okay, to bring out 2 to power 3 from here. In other words, we can rewrite every expression here as your x to the power of 3 plus 1 to the power of 3 close bracket. Then this other side we have here x to the power of 3 then minus 2 all to the power of 3 all over 3. Okay, close bracket or equal to 0. So if I rewrite this 3 all over 3, because 3 all over 3 will give us 1, which is same thing as 2 to the power of 1. Okay, so if I rewrite this, we're going to have this to be x to the power of 3 plus 1 to the power of 3, close bracket, okay, x to the power of 3 minus 2 to the power of 1 all over 3, then all to the power of 3 or into a square bracket. So let's change this to... Now, with this expression we have here now, we now recall our special algebraic identity. The first one, which says, if you have x to the power of 3 plus y to the power of 3, this is equal to bracket x plus y, close bracket, x squared minus xy, okay, xy plus y squared. Remember this identity? So what we have here now is same thing we have here now. Now, on the second side of it, if you have x to the power of 3 minus y to the power of 3, this is same thing as x minus y, close bracket, x squared plus xy plus y squared. Now, if we put these two special identities into consideration, we can rewrite these two expressions here and this one here in this form. Okay, so let's go ahead and write this in this form. And so this first one is going to give us here bracket x plus 1 close bracket. Here we're going to have this to be x squared minus your x there plus 1 all square, which is same thing as 1, then bracket. On this other side, we're going to have this to be your x minus 2 to the power of 1 all over 3, okay, 1 all over 3, bracket x squared, we have here to be plus 2 to the power of 1 all over 3, x plus 2 all over 3, close bracket, all equal to 0. Very easy. Any confusion? Just take time to digest this. It's very simple. Using this algorithm here now, okay, these special identities, if you use that to write this, the whole of this is going to give us. So let's erase this from the system. Okay. Wow. Now that we have this, we can now equate this to 0, equate this to 0, equate everything here to 0. And so if we do that, we're going to have this to be x plus 1 equal to 0, or this very guy here, x minus 2 to the power of 1 all over 3 equal to 0, or let's take this x to the power of 2 minus x plus 1 equal to 0, or then we have the last one, x to the power of 2 plus 2 to the power of 1 all over 3 x plus 2 to the power of 2 to the power of 3, okay, equal to 0. So we can solve this one by one, okay? So we take case 1, okay? So our case 1, let's take case 1, have here case 1. Case 1 says your x plus 1 equal to 0. So we have x equal to minus 1. Who got to the first value of x already from here now? So this is the first root. Case 2, which is this, we take this as case 2. And case 2 says your x minus 2 to the power of 1 all over 3 equal to 0. Okay, so let's rule this off. Okay, so from here, if we send this to this other side, we're going to have this to be x equal to, we have positive 2 to the power of 1 all over 3. So we've gotten a second value for x already. Okay, all right. Then from here again, let me rule this off. Okay, so from here we go to case 3. Case 3 is a quadratic equation. Okay, so we take case 3. Case 3, which says x squared minus x plus 1 are equal to 0. We now use the quadratic formula to solve this. So using the quadratic formula, we have our x is equal to minus b plus minus the square root of b squared minus 4ac, okay, all over 2a. Okay, from here, let's proceed. From here, let's proceed to this other side. If we impute our a is positive 1, b minus 1, c plus 1 into this formula, we're going to have our x. So have x is equal to minus, b is minus 1, so minus 1, close bracket, plus minus the square root of minus 1 all squared, okay, minus 1 all squared. Then we have a minus 4 dot, a is positive 1 dot 1 dot, and c is positive 1 also. So all over your 2 dot 1. So your dot here means multiplication. So again, this is going to give us positive 1 plus minus the square root of 1 minus 4 all over 2, which is equal to, we have here 1 plus minus root minus 3 all over 2. But record the identity, which says that your square root of minus 1 equal to your I, imaginary number. So if we introduce that to this expression, we're going to have this to be our x equal to your 1 plus the square root of 3 or into I all over 2. Okay, and so we've gotten another value. Mind you, we are having 2 roots from here now, okay? You have a plus minus, so we have 2 from here. In other words, let's rule of this guy here now. So we have here case 4. Case 4 of our expression. Let's bring out our equation for case 4, which was x to the power of 2, then plus 2 to the power of 1 all over 3, then of x plus 2 to the power of 2 all over 3 equal to 0. At the same time, here we are going to use the quadratic formula again. Now, using the quadratic formula, because of the power of 2 here, we must be careful here, okay? And so, our formula again says we have our x equal to minus b plus minus the square root of b squared minus 4ac all over 2a. If we impute our values here, then we're going to have this to be your x is going to give us here minus 2 to the power of 1 all over 3, then plus minus the square root of Here b is the same, minus 2 to the power of 1 all over 3 r squared, then minus 4 dot 1 dot 2 to the power of 2 all over 3. Okay, so let's extend our square root all over 2 dot 1. Okay, let's proceed on this other side. So if we continue from the other side, we're going to have our x equal to, we have our minus 2 to the power of 1 all over 3, then plus minus the square root of the minus will disappear. So we now have this to be 1 all over 3, okay, all to the power of 2, then minus 4 to the power of 2 to the power of 1 all over 3 all to the power of 2. Everything in all over 2. Okay, very easy. Because if we use these 2 to multiply this bracket, it will go inside to give us here 2 to the power of 2 all over 3, which is same thing. Okay, this and this are the same, so we can factor this out from this bracket here, and so we're going to have this to be minus 2 to the power of 1 all over 3, then plus minus the square root of, okay, so let's take this out here, 2 to the power of 1 all over 3 r squared, okay, bracket. If we factor this from here, we are left with 1, minus, we factor this from here, we are left with 4, close bracket, everything all over 2. Okay, so if we write out this, we're going to have this to be minus 2 to the power of 1 all over 3 plus minus the square root of, here we now have here to be 2 to the power of 1 all over 3, close bracket, all squared, then into minus 3, close bracket, all over 2. From here, okay, now, according to the law of surd, we say that if you have a, b, or to square root, this is same thing as a square root, okay, bracket, bracket, a square root of b. So if we apply that here, this will leave and 2 to the power of 1 all over 3 will come out. And so we're going to have our x equal to minus 2 to the power of 1 all over 3 plus minus then we have 2 to the power of 1 all over 3 into the square root of minus 3. Okay, all over 2. So we erase this again. Now, with this, we can factor out 2 to the power of 3. So if we do that, this is going to give us here 2 to the power of 1 all over 3, okay, into, we are left with minus 1 plus minus, then the square root of, here we're going to have 3i, or into bracket, all over, everything all over 2. So this is another root to our equation, okay? And so we can bring out all the 6 roots or the 6 zeros to this exponential equation. And so if we have to bring all of them out, the root number 1, yeah, x equal to minus 1, the first one. Second one, x equal to 2 to the power of 1 all over 3. The third one, we have 1 plus minus this square root of 3i all over 2. Then the last one, which is the one we just solved for, is 2 to the power of 1 all over 3, bracket, minus 1 plus minus the square root of 3i, close bracket, all over 2. And so these are the zeros of this exponential equation, Q, E, D. All right. Now, if we are to count the number of roots we have here, so we're going to have here 1, 2, 3, 4, 5, 6. So, because it's a 6-degree exponential equation. Okay, now the reason why I decided to bring out the second method is because the second method will bring out all the zeros completely, unlike the first method. If it is in case of OBJ exam or a competition exam where among the options, none of the imaginary roots are there, they go ahead to use the first method. Okay. But if you see some imaginary roots among the options there, then definitely you use the second method. Now you drop in the comment section your preferred method. Okay. At the same time, if you gain some value from this video thus far, give the video a thumbs up. Okay. Share with friends, share with family members, share with your colleagues that need this knowledge. Remember, Jakes loves you so much, and all of us at OnlineMaths TV love you so much. Thanks for always be there. We're proud of you. Bye for now.